Hi everyone, I'm Andie, and today I want to share some reflections and learnings from working in organizations that really live or die by their ability to navigate and operate with really large code bases. And my journey with large code bases began with EVE Online in 2010. This is a science fiction spaceship game that was launched in 2003, and it has been continuously evolved and upgraded ever since, and it's still operational today. And it then continued when I joined Unity right next door here in Copenhagen in 2018. And Unity makes a game engine, and this launched in 2005 and has also been continuously developed and upgraded since then. And I work there today, leading those tooling and technology teams behind the scenes that make it possible for us to make this quite large piece of software and release it to users to build their things with. So both of these organizations have large and really old. There are much older code bases in the world, but these are old enough for me to call them old. And I have learned over the years to treat these code bases as a kind of landscape that I need to map and navigate. And that the teams working in this type of code base very, very seldom can chart like a neat and straight Scrum burn-down chart when they are trying to deliver some kind of change in them. And this landscape is also not static, because today software is almost always made up of evolving components. It's continuously deployed and also situated in a changing software and hardware environment, because operating systems get upgraded, platforms evolve, or they get broke into in new creative ways, so you have to patch for security and so on. And I think I can say with confidence that every single plan that I have been part of making in these large code bases have met with some type of unexpected obstacles. Some mountain of, oh, we can't change this code, it has like tentacles everywhere, or, a bog of the last person who was familiar with this left 3 years ago. Or, sort of dense shrubs of who owns this? And little forest fires of those security patches that we have to deal with. And the dominant professional frameworks for delivering software today really only provide this kind of a velocity-obsessed factory metaphor, where we're supposed to deliver increments of software as if they were a little package. And not really any tools at all for thinking about how to map or understand or actively maintain a landscape of code to keep having agency in it. And software is an interesting medium because, at least in theory, once you make something and it doesn't become successful, it doesn't really cost anything to change your mind. As opposed to if you built a house or laid pipes in the ground, changing your mind is not free. But with code, most of the time, if things are not, successful or working, you could just kind of stop running it, drop it, delete it, right? And this is probably why, in a business context, there is such emphasis on delivery of software over maintenance of software. Because we don't yet know that something we build will be worth maintaining. It's a reasonable prioritization when building new things. But over and over again, I have found myself and the teams that I work with on old and demonstrably successful software, like code bases. They're out there powering products with like millions of users. They're clearly worth maintaining, right? It's proven beyond doubt. And yet we struggle in various forms with how to think about and organize that crucial maintenance work. So I'm here today to make the case for maintenance as something to obsess about for organizations that want to be sustainable with people and software in this type of code landscape. So I'm going to share some of my thinking tools that I use in my own obsessing. This is very much my day-to-day job, to obsess about this stuff, in the hope that they might be useful for you as well. So the first question I ask these days is, do we have a good understanding of what our code base looks like from this landscape point of view? Often there exists some kind of architecture diagrams. Maybe code ownership is documented in some repositories and code owners files and so on. But these are seldom paired with other information like organizational ownership or any regular maintenance needs that there might be around this code. These things tend to be implicit or something that engineers just sort of take care of as part of their day jobs, but it doesn't reach the level of awareness of the organization as a whole. And another important aspect is that often our software is built today from a kind of deep dependency tree of software that builds on software. And this kind of deep dependency tree very often shapes really what you're able to do, but is often also invisible to most people in the organization and becomes the territory of engineering. And my favorite approach for changing this lack of visibility and really enable shared situational awareness of the landscape is called Wardley mapping. And this is a pretty straightforward technique for starting in the user needs that your organization is trying to meet, and then just asking, okay, what dependencies do we have to actually in reality deliver that? And so we map out this value chain of all the things that are needed for our user need to be enabled. And doing this exercise very often uncovers critical things that are, you guessed it, unmaintained, unowned, or taken for granted because they weren't part of that kind of delivery cycle in a good while. Maybe they didn't need to be changed. And once an organization can see together that something underpins like the whole business, even if we haven't needed to touch it for a while, then usually the topic of maintenance stops being some kind of annoying slowdown and starts to become urgent for everyone, because you can see it so clearly that, oh, wait a minute, this critical thing here in the middle, does anyone actually know how to change that thing? And Wardley mapping as a technique then also helps us reason about which of the components in your landscape truly needs to be custom built because it's so specific to your organization that you have to, and which components might you consume as commodities or rent or buy off the shelf for another company, which really is you outsourcing the maintenance of that component to somebody else. But you probably have to maintain the integration still. And this kind of mapping can show technical dependencies and maintenance challenges in the context of the business capabilities and user needs that they are part of making possible, so that the discussion can be available for every role in the business and not just something that is like for engineers. Because they are often the only people in the organization who have visibility on this stuff. Because it's a lot and it's technical and it's complicated, right? We kind of hire engineers to take care of it. But I think there's so much important stuff here that the whole business needs to have enough visibility to have a meaningful discussion about this. Which brings us to the topic of how successful teams today tend to make space for this kind of work. Many organizations today do recognize that sustainability or maintenance work is kind of necessary to manage a long-running technical ecosystem. And so this 60-20-20 model is kind of emerging as a pattern that a lot of organizations adopt. 60% of a team's bandwidth or backlog that you take into a sprint or whatever is thought to go into sort of new features, 20% to fixing bugs or enhancing the existing features, and then 20% into technical enhancements. And this is a great model, and I really recommend it. It's working great for us at Unity in many ways. But there's usually a challenge with that technical enhancements bucket, because I've seen it so many times become a black box. It's basically a bucket for whatever engineering says is necessary for us to do. And the problem with only engineers understanding that, for me, is not that we don't trust engineers, but when the rest of the organization doesn't understand why, very often this crucial work has to fight for priority, and very often doesn't make it in, right? For teams that drive really hard on delivery and direct customer value, what's the customer value of upgrading the metrics SDK 1 version, right? We might hear a product manager ask. And so this maintenance debt can really pile up, such that if you were to adopt this 60-20-20 model, you might have depth enough that just allocating 20% to it doesn't actually cover the needs, right? And I would ask you, is this type of maintenance work done as a kind of shadow IT in your company, with engineers either fighting to get it on the backlog, or often what I have seen is they just do it in their spare time, maybe outside work, maybe on work hours, but it's easier to not tell anyone than fight for it to get in the sprint or on the backlog, right? You just do it anyway, right? And if this seems to match even a little bit what goes on in your organization, I would really say that it might be a good idea to first map your dependency landscape and then ask engineers to explain maintenance work that they might be doing without it being in tickets or on the backlog. So now, if we assume we have created a decent map of our software landscape, we may also realize that if we want to have full agency in this landscape, we require at least one human to be able to open, understand, and meaningfully modify the code for each part of the landscape. Because otherwise, these areas with roots everywhere, or where no one currently is familiar, they can become true hard blockers for any progress that you might want to make in the moment, right? These are the kind of obstacles we encounter when trying to deliver something unrelated. And when looking into software incident response, there's a group of researchers who created this model for understanding how humans understand and intervene in running software systems. And the point in this model is that the human work in a system happens above the line, this line of representations, because you can't see code, right? So if you have a complex system that's actually running, you have to really collaborate and operate with your mental model of what's happening. And that's how humans can operate on the system. And this model made it super clear to me that we can think of these mental models as something that also need maintenance, upkeep in a way. And by maintenance here, I mean somebody has it loaded in their brain, right? And if they're not loaded into the brain of a human at the moment, because we didn't pay attention to it for ages or whatever, we probably don't have very good agency, even if we have access to our code still. So for our thinking on maintaining agency in a software landscape, it really begs that question: does anyone even have a working mental model of this part of the system? And if no one does, would we be able to resurrect one? And how long would it take? Interesting questions, right? So this perspective tells us, or has told me, to get more serious about mapping ownership, for example, which is often our proxy for, does someone understand this? And then finding any ownership gaps. So at Unity, for example, with a really large monolithic code base, we get very explicit about ownership. We have additional metadata files across the whole code base that basically connect code files with cross-functional teams and bug backlogs and so on, so that we have agency. And this has let us identify, gaps in that ownership, for example. And these insights from this data, they inform staffing decisions and prioritizations all the time, because we have recognized that, customers send us bugs all the time. If we don't have anyone who can fix those bugs, we have, a problem, right? And so we have to maintain also the mental sort of loading of the code base to be successful. And a wish to maintain this agency can also be a more clear driver for things like documenting architectural decisions, documenting code and each change to it properly, perhaps some cross-training between teams, or a way to test the onboarding documentation for how you can contribute to some part of the code base. And again, I've often seen engineers be alone in caring for these things. And I can understand why, but the surrounding functions might see this as sort of a slowdown or a kind of annoyance when delivery deadlines are looming, for the actually important. But these practices are part of proactively maintaining agency in a large software landscape. And so if you've actually done this exercise, these things can go from nice to have to something that's really crucial. And here's one of my favorite examples of a company that I think really mapped and understood its dependencies. When you have financial software systems written in a very old programming language, you realize that you have to actually create your own school to have humans who are even able to begin to work with these systems. And if someone here works at STB, I would love to hear the story of how this came about. So the point of all this mapping and reasoning and taking maintenance more seriously is to maintain agency in your own software landscape so that it can continue to serve your organization's purpose. And have the full organization bought in on why a gradual re-architecture, automated dependency patching, documented and assigned ownership, or even a whole training academy might be items for the top of the backlog. So maintenance can be agency, agility, and survival. And if your organization can start to see the value of it more clearly, I think it can get you across some pretty tricky terrain, also with work that is not maintenance. And if you have a newfound interest in maintenance after listening to this, I really recommend learning about Wardley mapping and also reading Marianne Bellatti's really great book, Kill It With Fire, which is on how to manage legacy systems. So, thank you.